I'm Anil Kumar, and here's a practice test question for you. We are given a periodic function. You need to write equation of this periodic function from the given graph, right? So that is the test question for you. You can pause the video, copy the question and write down the equation. And let us see how to do it. My suggestions are, we'll begin with the very basics which we learned, and it will be a good review of all the concepts which we have learned so far in these set of videos. Now, to get the equation, the critical things which we should know are maximum value, minimum value, and time period. So we'll start with maximum value. So I'm just writing max for maximum value, and also we will read minimum value from the graph, right? So the maximum value from the graph is the value which is seems to be 1. So maximum is 1. Minimum value is -3. So minimum is -3, right? So this is the minimum value, -3. So let me write -3 and 1, maximum value. Once we know maximum and minimum value, we can find two things. And those two things are, can you tell me? X's, right? So X's, which is average, right? So you could say average. Average value, that means maximum plus minimum divide by 2. Is that okay? And in this case, it will be 1 plus -3 divided by 2. And that is indeed -1. So it is -2 divided by 2. It is -1. So we'll draw -1 as the axis. Y equals to -1 is the equation of this axis. Is that okay? Now, as you can see, this axis is a horizontal line. We normally prefer to write equation of axis. So sometimes whenever they say write down equation of axis, then you have to write y equals to -1. See, y value is -1 all throughout along the axis. Now, what is the amplitude? To find amplitude, we can follow two methods. One method to find amplitude is, let me use another ring. So we say amplitude A is equals to maximum, this is minus, that is take difference. So we do maximum minus minimum divide by 2, right? So which is 1 minus -3 divided by 2, which is 1 plus 3 divided by 2, which is 4. And that gives us the value of 2. So the amplitude for us is 2. That is one way of looking into it. The other way of looking into it is how far away the max is from the axis. So that means how far away maximum or minimum is from the axis. So the alternate way for finding A is equals to maximum value minus the axis, right? So that also gives you the same answer. Maximum is 1, axis is -1, so -1, that gives you 2. So amplitude in our case is 2, right? So that is how you could get amplitude A. Now let's get back to the other part. So I hope that's a good review of what we learned earlier about characteristics of periodic functions. Now let us try to write down the equation of this function. So we could write sine function, right? So we could write sine function, or we could write this as a cosine function, correct? So let me first show you how to write down the equation for sine function, okay? So if you see one part of the wave, let us consider the point. So we are always looking at 5 points, right? So 5 points, I'll consider these 5 points for my wave, okay? So these are my 5 points, one full wave. And in this one full wave, what is the time period? So the time period, actually I should, if I start from here, I close it there, okay? Fine. So do not consider that. 1, 2, 3, 4, and 5. Those are my 5 points. Fine. Well, this is an important point for me since I am interested in finding the time period. So time period is horizontal distance between two similar positions, right? So two similar positions, let's take minimum in this particular case. So this horizontal distance for us is time period t. That point is at 2.5. This is at 0.5, right? So this is 1. So that is 2. 2.5. So 2.5 minus 0.5. So the time period for us is 2. So 2 units is our time period. what we learned here is if that the time period is 2, then the horizontal stretch or the stretch or compression factor is 1 over 2, right? So the K value is kind of 2 pi by 2 or 360 by 2. So we will write down the equation in terms of the radians for the time being. Okay, before moving forward, let me write down a general equation and then it'll be easy for me to explain what I'm trying to do. A, the amplitude, sine x minus phase shift, so I'm using P for that, plus vertical translation, which is D. And the K factor which I am saying is being inserted here, which I forgot to write. So that is the horizontal stretch and compression factor. Okay, so let me rewrite the equation. So we are looking at an equation which is y equals to A sine K times x minus P plus T, right? So yeah, that is the equation which we are looking for. Now, how is K related with time period? K is equals to 2 pi by T. 2 pi by T if you're working in radians. So in this particular case, K will be, time period is 2, so it is K will be pi. 2 pi by 2 is pi. So we get the value of K. Now phase shift. You could consider phase shifts that the wave has started from this point, which is 1 unit away, or you could also consider that the wave has been reflected. Do you see that? Wave has been reflected. So these are two different ways in which you should consider phase shift. So we will incorporate both the ways to write different equations. Okay. So let's write down first equation, which is A for us is 2. Since it has been reflected, I'll write minus 2. Sine of K, which is pi for us. X. If I am considering reflection, then there is no phase shift. So P is 0. D value is the axis minus 1. So y equals to minus 2 sine pi x minus 1 is one way of writing the equation. So this is one way of writing the equation. Now let me show you the alternate. Let us consider alternate equation. Now in this equation, we'll consider the phase shift. So imagine that the sine function has moved 1 unit to the right and 1 unit down. So D value is minus 1 and P is plus 1, correct? Since it moves 1 unit right. So I could write this equation as y equals to 2, which is the amplitude, since the amplitude is twice. So 2 sine K value remains same, which is pi. However, there's a phase shift. It moved 1 unit to the right. So x minus 1 minus 1. So that becomes an alternate equation for the same graph, right? So that is how we can actually write two different equations, both in sine, for the given graph, correct? So that is how we should be doing it. Now here is a question for you. You need to write cosine function for the given graph. As you know, cosine function is translation of sine function, right, by quarter of the cycle. So you can use that knowledge to write this or translate the equation from sine to cosine, or you could start fresh. Cosine function starts from maximum or minimum. So if you consider maximum, you could write a straight function starting from here or from there. If you're thinking about minimum, then you use minus cosine x, and that is the point to start from. That means the p value will be 0.5. I hope that helps you to get the answer for this. We'll take up this question once again with both sine and cosine functions. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you.